Okay, good morning again, everybody. So, welcome to week number 7 of the semester. So, we're halfway through the semester. Yay! In fact, I think on Saturday we'll start the reading break. So, makakapahinga na tayo ng kaunti. I know the semester might be challenging for some of you, not just because of your ACAD load, but because of the sudden shift again in the learning modality. Alam ko yung iba sa inyo still grasping with the blended learn. I mean, hindi nga siya blended kasi nakadepende siya subject per subject. So you might be attending face-to-face classes and then you need to rush to your dorms or somewhere else that you have internet connection para dun sa susunod yung klase. So next week would be a welcome for will be a welcome change for all of us kasi makakapahinga tayo ng konti. Pero I don't know if you can spend it too much for leisure kasi meron tayong midterm exam, right? Right after the reading break. As I mentioned in the backstage, October 31 was declared to be a holiday. So we need to move our midterm exam. So the new date would be November 7. Still a Monday. This is the Monday after the supposed schedule, na October 31. But now the time is 4 to 6 p.m. So, meron ba sa inyong hindi free ng oras na to? Will you have any problem with this? So if you will have problems with this, just let me know. But we can arrange some things because I also reserve a room for 2 to 4 p.m. in case you do have conflicts for 4 to 6 p.m. Pero ginawa na namin 4 to 6 p.m. gawa nung I know some of you might be taking math 174. So merong laboratory ng 1 to 4. So para hindi kayo masyadong haggard, so ginawa na namin, hindi pala kasi para hindi mag-overlap. So ginawa na namin 4 to 6 p.m. yung bagong schedule ng midterm exam. Okay. And the midterm exam is moved from October 31 to November 7. The new schedule is 4 to 6 p.m. Now, it will be at the math building. So, may tatlong rooms. Hindi pa namin finalize yung room assignment. So, I will just announce our room assignment for this date. Pero sa math building lang naman. Okay? Any questions? By the way, the target coverage will be up to inverse linear operators. Inverse linear operators. Tingnan natin mamaya kung anong section to under chapter 3. Okay? So any concerns with this new schedule? I hope this is fine. And then I guess I still owe you a couple of homeworks. So hopefully this week or during the reading break, I can finish grading them. I'll upload my answer keys or my solutions to those homeworks. Tapos pwede nyo i-check at kung sinagutan nyo yung more than what was required. You can also check your solutions or check my solutions for those items, compare our answers, and hopefully magtama. Kung medyo may discrepancy, just let me know. Departmental, yung Math 151 exam. Kaya kaya kailangan ng common time, right? Pwede sana na during class hours, kaya lang iba-iba tayo ng time slot, yung tatlong Math 151 sections, and we decided, nag-meeting kaming tatlo at the start of the SEM, and we decided we'll have a departmental exam. Okay? Kaya it's also a good development na na-move yung exam para ma-move din yung coverage, kasi medyo behind tayo than other sections. But I will insist on our pace, kaya sa bilisan natin tapos hindi naman natin masyado naintindihan yung topics, alright? So, okay, so just let me know if you will have any problems with that schedule. Pero that would be the regular schedule for the midterm exam. It's face-to-face, so kindly make the appropriate arrangements. And now for this week, we'll start going to we'll start discussing chapter 3, and chapter 3 will cover our solution schemes for general linear differential equations. Chapter 2 dealt largely on linear first order differential equations. All right. So lahat ng tiningnan natin mga methods doon ay applicable sa mga first order linear differential equations. I'm trying to think, meron ba tayong technique para sa mas mataas sa first degree? Sa first order? Parang lahat y prime pa lang yung involved, no? Hindi pa tayo nag-involve ng y double prime, y triple prime, and so on. And we seldom dealt with nonlinear equations, all right? So parang talagang yung chapter 2 ay these are the basic methods because they really apply to the most basic kind of differential equations, yung linear first order. Linear, ibig sabihin yung coefficients na nandun sa ating differential equations ay functions of x lamang, tapos walang y terms or derivatives ni y na nagsasama sa isang term, tapos ang order ng derivative ay at most 1 or exactly 1 lamang. So in this chapter, we will look at a wider variety of differential equations. Titingnan natin ano naman or paano natin isosolve yung mga linear, yung mga ODEs of higher order na linear pa rin yung form. Alright? So ang pinagkaiba nito sa chapter 2, posible nang mas mataas yung order. So we'll be seeing order 2, order 3 derivatives that will occur in our differential equation. But that doesn't mean that you can throw away what you learned from chapter 2 kasi most of the methods na titingnan natin ay kakailanganin yung mga topics na na-discuss natin in chapter 2 because there's a transformation that we can perform in order to translate a higher order differential equation to say a first order differential equation. So after that change in variables, bababa siya sa isang first order linear differential equation. So kakailanganin nyo pa rin yung mga techniques na nakita na natin in chapter 2. Alright? So yun nga lang, ito ay mas may additional step bago natin magamit yung mga nakita nating techniques from chapter number 2. Alright? Now, this week will be sort of an introduction to chapter 3. So medyo chill lang tayo ngayon. Kakaunti yung mga computations na gagawin natin because first, I need to present to you the general theory behind general linear differential equations. So here's the outline for the chapter. Ano? So today we'll do general linear differential equation and hopefully linear independence. Tingnan natin kung kakayanin natin yung general solution. If not, we'll do that on Friday. Pero ang target na kasama sa midterm exam ay hanggang 3.7. So, pero kung hindi natin matatapos yung 3.7, say next week, I will propose na medyo bawasan yung coverage ng midterm. But let's see how it goes because if we can finish more than chapter 3.3 this week, then I think we are in a good shape to meet the section 3.7 coverage for the midterm exam. Okay? So that's the plan. Let's try to have 3.7 siguro after hanggang week after the reading break para sa November 7 ready kayo para dun sa 3.7. So let's get going. Now the chapter objectives are as follows. So at the end of the chapter, you should be able to meron akong ilalagay na number 0, determine whether an ODE is a general linear differential equation. Then after that, we're going to look at the Wronskian of functions. Makikita natin ano yung tinatawag natin na Wronskian, saan siya ginagamit at paano siya kino-compute. Then we'll look at solving homogeneous differential equation with constant coefficients. Makikita nyo, napaka-specific pa rin. Ano? So kahit nasa general linear differential equations tayo, yung mga solution schemes natin nakadepende pa rin dun sa itsura ng differential equations. At napaka-specific. Alam mo, sa number 2, homogeneous differential equation pero constant yung coefficients. Kasi hindi natin kayang isolve lahat ng mga ODEs. Kaya nga sa Math 175, makikita nyo paano nagsasolve numerically o kumukuha ng approximate solution sa mga ODEs. Kasi hindi lahat ng mga ODEs ay kaya nating isolve. Alright? Then, the third objective is to solve non-homogeneous. Makikita nyo kasi pag nagsasolve ng non-homogeneous differential equations, kailangan nating isolve muna yung homogeneous equation at humanap ng isang particular solution. And then the last one is to demonstrate an understanding of differential operators and inverse differential operators. So there's a lot in our plates in chapter number 3. So let's get moving. Ano? So simulan kagad natin. Section 3.1. In this slide, I'm just defining what a general linear differential equation is. So ibig sabihin, or this is telling us that a general or standard linear differential equation, or GLDE for short, of order n is any ODE that can be written in this form. Okay. Una, siya ay general kasi hindi na tayo nagbibigay ng imposition dun sa order ng derivatives. Alright? In chapter 2, nakita natin ay first order linear differential equations. In this particular case, we will relieve the or we will take away the restriction on the order of the derivatives present. Kaya siya general na. So kahit ano pa yung order ng derivatives, it's okay for us. All right? So you see here we have an order n derivative. That is fine. Second, we're saying it is linear because there is no mixing of y's or derivatives of y in a single term. Look at the first term. It only has the nth derivative of y. The second term has the n minus 1 derivative of y. Tapos all the way up to y prime and then y. Hindi naghahalo sa isang term si y at saka si y prime. Tapos wala ring komplikadong function ni y o ni y prime doon sa derivatives. So basically, if you can write your differential equation so that you have derivatives in each term and the function itself on each term times a function of only x, then it is a linear differential equation. All right? So yung linearity dito ang binabanggit ay linear in y and its derivatives. And it's wrong spelling. And its derivatives. Okay? So hindi dapat nagsasama si y at saka yung mga derivatives niya in a single term at walang fancy function of y or its derivatives. So essentially, pwede ka lang magkaroon ng nth derivative times a function of x. It doesn't matter how a sub 0 looks like. Pwedeng meron ditong cosine, pwedeng merong exponential, pwedeng magkaroon dito ng inverse trigonometric as long as function lamang siya ni x. Wala ng y o derivative ni y na involved dun sa coefficient. Right? So we call a sub 0 of x, a sub 1 of x, a sub n minus 1 of x, and a sub n of x as our coefficient functions. So isang general standard linear differential equation, meron ka lamang mga derivatives ni y accompanied with coefficient functions na functions lamang ni x equals a forcing term. And the forcing term is also just a function of x alone. All right? So if you can write your ODE in this manner, then that is a GLDE. Right? GLDE yung tawag natin sa kanya. Or equivalently, we can, there's a shorthand notation for this. Kung medyo nahihirapan na kayong isulat itong mga derivatives na to, all right? So this is the Leibniz notation for the derivatives. Shortcut sa kanya ay operator D na lamang. So yung nth derivative with respect to x, pwede nyo lamang palitan ng d to the power n. Right? Ang ibig sabihin nito ay nth derivative with respect to x whenever the variable of differentiation is obvious. For us, that's fine kasi isa lang naman yung independent variable natin, so isang klaseng derivative lamang yung ating kinocompute. It's a derivative with respect to the independent variable, which is, and there's only one independent variable in our differential equation, so okay lang na instead na dn over dxn yung gamitin, palitan na lang natin ng dn. Alright? So, yun ay kung medyo nahihirapan kayong isulat yung fractional notations. Ano? Pero probably I'll stick to this notation kasi mas ano yan, mas sanay ako sa ganyang notation. Okay? And so kung meron kang GLDE, pwede pa natin siyang i-classify based on its normality. Kailan nating sinasabi ang isang GLDE, para mas mahaba, no? Ang GLDE, kailan ang isang GLDE ay normal sa isang interval? Well, there are two conditions that should be met. Number one, the coefficient functions together with the forcing term must be continuous on the interval I. So, pag na-determine mo na, meron akong GLDE, tingnan mo ngayon yung coefficient functions. Then check if all of those coefficient functions and the forcing term are continuous on the given interval. Okay? Pag continuous sila, meron pang isang condition kang dapat i-check. Dapat ay never nagzi-zero yung a sub 0 over the interval. Ibig sabihin, yung coefficient ng highest derivative ay hindi dapat nagzi-zero sa buong interval. Remember, ang itsura ng ating GLD ay ganito. A sub 0 of x times n partial derivative of y with respect to x plus a1 of x times n minus 1 derivative with respect to x ng y all the way up to a sub n y equals 0. Okay, equals r of x. Yung coefficient ng highest order, okay, yung a sub 0, yung coefficient ng highest order derivative ay dapat never nagzi-zero. There should be no x in the interval I that will give us a sub 0 of x equal to 0. Okay? So dapat ito ay hindi lamang continuous. Dapat never siyang magzi-zero sa buong interval I. If these two conditions are met, then we say our GLDE is normal on an interval I. Okay? Everything's clear so far? Maybe it would be clearer if we look at specific examples. All right. So tingnan natin. Number 1. Question, is this a GLDE? General linear differential equation ba ito? Oh guys, kahit reaction man lang, ano? So kahit thumbs up na yes or no. Okay, thank you. Yeah, thank you Zai and Kiefer. Yeah, this is a linear differential equation. Ano si a sub 0? Ano mo ng order? This is an order. Yes, Zaira is correct. This is an order 3 GLDE. Tapos ang a sub 0 natin ay 1. Ang a sub 1 natin ay x minus 1. So ito si a sub 0 of x ay equal kay 1. This is our a sub 1 of x. And then this is our a sub 2 of x. Wala pala tayong ang a sub 2 of x pala natin ay 0. Kasi si a sub 2 of x siya yung coefficient ng first derivative. Tapos itong 3 na coefficient dito, siya si a sub 3 of x. Tapos ito si r of x. Alright? So yeah, this is a GLDE of order 3. And then look at the coefficient functions. We have the constant function 1. We have the linear function x minus 1. We have the zero constant function a2, and then we have the constant function as our a3, and then we have x squared as our forcing term. All of these 4 functions are continuous on any interval, right? So continuous, lahat ng mga coefficient functions natin, pati yung forcing term sa lahat ng real numbers. And look at a sub 0, the coefficient of the highest order. So ito ay never nagzi-zero sa kahit anong interval. So that means we can say that this general linear differential equation is normal on any interval. Yeah, on any interval, period. Okay? Clear? Okay, another example. X minus 1 dy over dx plus 3y equals x squared. Again, this is a GLDE, right? Kasi never nagmi-mix yung y prime at saka si y. Tapos si y prime at saka si y ay hindi napapaloob sa isang komplikadong function sa kanilang bawat terms, right? So this is general linear of order 1 kasi 1 yung highest derivative. Now, the coefficient functions are x minus 1. Ito yung a sub 0 natin. Ang a sub 2 natin ay, ang a sub 1 natin ay si 3. Ang forcing term natin ay x squared. Question, is this normal on any interval? Normal ba to sa kahit anong interval of real numbers? Yes or no? Okay, sabi ni JR at saka ni Kiefer, saka ni Zaira ay hindi daw ito normal sa lahat ng real numbers. Zaira is correct. Okay, bakit? Kasi when x is equal to 1, the a sub 0 that we have, which is x minus 1, will become 0. Remember, nagiging normal ang isang GLDE kapag ka never nagzi-zero sa given interval yung a sub 0. Ang a sub 0 natin ay x minus 1. Posibleng mag-zero yan. In fact, nagzi-zero to when x is equal to 1. So we can say that this GLDE is normal on any interval that doesn't contain x equals 1. Okay? So basta si 1 ay hindi kasali sa interval that you're considering, then this ODE is normal. Okay? Kasi continuous naman lahat ng coefficients, yun nga lang nagzi-zero ito when x is equal to 1. Okay? How about this one? Y double prime cubed plus 3y equals 0. Spoiler pala, nakalimutan akong tanggalin. Hindi to linear. Bakit hindi siya linear? So hindi kagad siya GLDE, so it doesn't matter to talk about normality ng equation. All right? So bakit hindi to linear differential equation? Yeah, Kiefer is correct kasi merong exponent yung y double prime. Okay? So, yeah, John Rancis may, yeah, you're also right. Di ba, ang requirement natin, hindi magsasama yung y at saka derivatives niya. Well, that occurred here, right? Hindi nagsama si y double prime at saka si y. Kaya lang, si y double prime ay napaloob sa isang function. Napaloob siya sa something cubed. So that makes it non-linear. Kasi dapat walang exponent, hindi nasa loob ng mas komplikadong function pa yung mga derivatives at saka si y. Alright? So the fact that y double prime is raised to the third power makes this ODE non-linear. Okay? So hindi to linear. About this guy, number 4. Is it linear? GLDE ba yung number 4? Sige nga, come on. GLDE ba yan? Mabagal bang internet ko or nag-iisip pa kayo? Alright? Kasi halos sunod-sunod lumalabas yung mga sagot eh. Kiefer, JR, and Reynald and Zaira, you're right. Oh, by the way, clarify ko lang, Reynald, no? So, pag GLD yung tanong, it doesn't matter on which interval you are. Ang requirement lang para maging GLDE ay hindi nagsasama si y at saka yung mga derivatives niya in a single term and hindi napapaloob sa isang non-linear function si y saka yung mga derivatives niya. So essentially, I can say that this equation is a GLDE with respect to any interval, all right? Wala tayong interval na kino-consider kapag ka nag-GLDE. But I think what Reynolds is saying is that ito ay normal sa kahit na anong interval except yung nagko-contain ng 2 at saka -1. Because this is a fifth order GLDE kasi ang pinakamalaking order ng derivative ay 5. So ang a sub 0 natin ay ito. Tapos ang a sub 1 natin, ang a sub 2, a sub 3, ang a sub 1 at saka ang a sub 2 ay parehas 0 kasi wala tayong term for the fourth and the third derivative. Tapos ito ay a sub, a sub 3. Tapos ang a sub 4 natin ay 0 uli. Tapos ang a sub 5 ay 2. So basically, lahat ng coefficient functions, so you have this x minus 1 times x plus 2 plus the constant function 1 plus the constant function 2. Tapos yung mga missing derivatives, ang coefficients nila ay constant function 0. Yung forcing term natin ay 2x. Lahat ng mga coefficient functions na yan ay continuous. So meron siyang chance na maging normal. Pero pag tinignan natin yung second requirement para maging normal, kailangan nating i-inspect si a sub 0. Again, si a sub 0, siya yung coefficient ng highest order. So in our particular case, this is our A sub 0, right? Kasi ito yung sinasabi ni Reynolds kanina. Kasi kailangan, second condition, para maging normal siya, dapat never nagze-zero sa given interval yung ating A sub 0. But if you look at A sub 0, obviously, this will become 0 when x is equal to 2 or x equals negative 1. So, ibig sabihin, kapag yung interval I mo ay nagko-contain ng 2 at saka negative 1, then that means actually yung connective by or. Pag kinontain niya si negative 2 or si negative 1, ibig sabihin hindi na normal yung GLDE natin sa interval na yon. For instance, if you consider the interval 0 to 5. Sa interval 0 to 5, hindi normal itong GLDE na to. Kasi sa interval 0 to 5, yung A sub 0 natin ay posibleng mag-0. If you recall condition 2 for normality, kailangan never nagzi-0 dun sa given interval si A sub 0. Alright? Pero dahil sa 0 to 5, nandyan si positive 2, ibig sabihin magzi-0 itong A sub 0, which is a no-no for normal GLDEs. So that's why we can conclude that this ODE is normal, all right, on any interval that doesn't contain either 2 or negative 1. All right, dapat hindi niya i-contain si 2 o kaya si negative 1. If it contains at least one of those two, then automatically hindi na siya normal. Okay? So dapat ito ay or yung connective, right? Kasi pag may isa siyang kinontain, automatic hindi pa rin siya normal. Alright, is that clear? Okay, so I hope that's fine. And then let's revisit the concept of homogeneity. So, but we already mentioned this, pero in the context of first order, actually hindi pala, no? Dun sa chapter 1, binigay ko na to. Ang isang GLD ay homogeneous kapag ka zero function yung constant term. Alright? So if you write your general linear differential equation, and then the forcing term is identically the zero function, okay? So ibig sabihin, meron kang homogeneous differential equation. Pag zero, yung right-hand side nung standard form nung GLDE. And then it is non-homogeneous if R of x is not identically zero all throughout the interval of consideration. Okay? So kung non-zero function yung R of x, hindi siya homogeneous. Kailangan maging zero to para siya ay maging homogeneous. Okay? And that brings us to probably the first main theorem for this chapter. So kapag ka daw meron kang isang homogeneous equation, siya yung naka-equation 2. So meron kang homogeneous GLDE. It's homogeneous because the right-hand side, the forcing term, is identically zero. Okay? Kaya siya homogeneous. Tapos, kapag ka daw nakakuha ka ng dalawang solution, si y1 at saka si y2, silang dalawa ay parehas solution ng homogeneous equation 2. Okay? Ibig sabihin daw, kahit anong constant, C1 at saka si C2, sila, etong sum na to, ay solution pa rin ng equation 2. So this is what we call a linear combination. Linear combination of y1 and y2. Linear combination sila kasi pinag-a-add lang natin yung scalar multiples ni y1 at saka ni y2, right? So any linear combination is always the sum of multiples of y1 and y2. So meron akong isang solution, may isa pa akong solution, kukunin ko yung linear combination nila. It's just an arbitrary constant times the first function plus another arbitrary constant times the second function. Kahit ano pa si C1 at saka si C2, ang tawag natin dito ay linear combination. So essentially, Theorem 3.1.1 is telling us that the linear combination of any two solutions of a homogeneous equation is yet another solution of the homogeneous equation. So kung meron kang dalawang specific solutions ng homogeneous differential equation, makakahanap ka ng infinite family of solutions pa dun sa homogeneous ODE mo. Paano mo mahanap yung infinitely many solutions na yon? kunin mo lang lahat ng posibleng linear combinations ng dalawang solutions na yon. Alright? So, ibig sabihin pala kapag meron kang dalawang solutions sa isang homogeneous ODE, there will exist infinitely many solutions. Kasi kahit anong linear combination ng dalawang solution na yon ay panibagong solution pa ng ODE. Alright? So let's try to prove this. Actually, the proof is simple. Alright? So when do we say nga na solution ang isang function ng ODE natin? How can we verify that a given function is a solution of our ODE? Sige nga, before I write the proof. Okay, ang isang function ay solution ng isang ODE kapag nasa-satisfy niya yung ODE, right? So the claim here is if y1 and y2 are both solutions to the DE, right? Yung linear combination nila ay solution pa rin daw ng ODE, right? So here we want to show that y equals c1 y1 plus c2 y2 is a solution to the ODE dun sa equation 2. Alright? So, ang gagawin ko lang, papalitan ko lang lahat ng mga y's na nandun sa left-hand side ni equation 2 by c1 y1 plus c2 y2. Alright? Tapos gusto ko ipakita na pag sinimplify ko yon, mag-i-equal siya kay 0. Okay? So, let's try to do that. Okay? So, now, let's do this. Okay. So lahat ng y's, papalitan ko lang na to. Just bear in mind that C1 and C2 are any real numbers. So sila ay kahit anong real numbers. Si Y1 at saka si Y2, sila ay solutions din na equation 2. Alright? So ngayon, lahat ng y's, papalitan ko nito. So I'll have a sub 0 of x times the nth derivative with respect to x ng C1 Y1 plus C2 Y2 plus a1 of x times the nth derivative, n minus 1th derivative of itself. Yun nga lang yung ayoko dito sa proof na to. Ang daming isusulat. Alright. Plus, hanggang makarating tayo sa an of x times c1y1 plus c2y2. Okay? Gusto kong ipakita na ito ay equal kay 0. Kasi pag equal to kay 0, ibig sabihin, yung pinampalit ko kay y, alright, yung c1y1 plus c2y2 ay solution din ng equation number 2. Alright? So, bine-verify ko na siya ay solution kasi yun yung claim dun sa theorem. Okay? Now, here, I'll use the linearity of the differential operator, right? So, gusto kong kunin yung nth derivative ng c1y1 plus c2y2. Right? So, derivative ito ng sum. So, pwede ko siyang hatiin sa dalawa. So, pwede siya maging a sub 0 of x times nth derivative with respect to x ni c1y1 plus nth derivative with respect to x ni c2y2. Alright? So, dahil ang derivative ng sum ay sum lamang ng derivatives. Agree? So, pwede ko itong gawin sa lahat. Hanggang makarating ako ng a and x ng ang tamad ayaw isulat lahat ng derivatives. So, sige na, sulat ko hanggang sa second to the last term. So, equal to, dun sa taas, tapos ito ay a sub n minus 1 of x times the derivative with respect to x ng c1 y1 plus derivative with respect to x ng c2 y2 plus this guy. Pagkasyahin ko na lang siya doon. Okay? Okay so far? So ginamit ko lang yung property na ang sum ng derivatives ay derivative ng sum. Okay? Tapos ano pang mapapansin ko? Tingnan mo to. Si C1 ay constant. Nasa loob siya ng derivative, right? So it's a constant times the derivative. Remember the derivative of a scalar multiple? Ang derivative ng scalar multiple ay scalar multiple ng derivative. In other words, yung constant ay lalabas lamang ng derivative. Alright? So let me do that. Okay, pero dito na sa kabilang parte. Okay? So ang gagawin ko lang naman, ilalabas ko to, yung constant. Oops, sorry. Ang tamad kasi ayaw na lang isulat no? So, eto, ilalabas ko nung derivative. So, pupunta siya dun sa harap. Ito ay pupunta rin dito sa harap. Tapos ito, pupunta sa harap. Tapos ito ay pupunta rin sa harap. Okay? Tapos ngayon, i-expand ko to. So what I'll do is I'll distribute a sub 0 of x to the two terms. Gagawin ko to sa bawat term. Alright? So ito, madidistribute din doon. Tapos itong a yan, madidistribute din sa dalawa. So essentially, what I'll have is a sub 0 of x times c1 times nth derivative with respect to x ng y1 plus a sub 0 of x times what? C2 nth derivative with respect to x ni y2 plus susunod na term dito ay ganun din, same pattern. So I'll have a sub 1 of x times c1 n minus 1 derivative with respect to x ni y1 plus a sub 1 of x times c2 n minus 1 derivative with respect to x ni y2 plus and so on hanggang makarating tayo kanino kay a sub n minus 1 of x c1 derivative ni y1 with respect to x plus a sub n minus 1 of x c2 derivative ni y2 with respect to x plus yung last na a sub n of c1 y1 plus a sub n of x c2 y sub 2. Okay? So in-expand ko lang siya. And then look at the following terms. So ideally, i-ano ko siya, i-rearrange ko yung mga terms. Kasi tingnan nyo itong mga to. So what can I do about the terms here? Now, all of these terms has a C1. Alright? So pwede kong i-factor si C1. See? Meron silang mga C1. So pag na-factor ko na yung mga C1s, ano mangyayari? Magkakaroon lang ako ng C1 times a long sum dun sa first group, right? Ano yung long sum na yun? A sub 0 times the nth derivative of y1 plus a1 times the n minus 1 derivative of y1 plus until I get to a sub n minus 1 times the derivative of y1 plus a sub n times y1. Saan equal yung mahabang sum na yon? So essentially, I'll just go to the next slide, all right? So ganito yung sinasabi kong mangyayari. So yung first group, magiging a sub n of x times nth derivative ni y1 with respect to x plus a sub n minus 1 of x n minus 1 derivative with respect to x ni y1 plus hanggang makarating ako sa sorry, baligtad pala. Ito ay a sub 0 of x. Ito ay a sub 1 of x. Hanggang makarating ako kay a sub n minus 1 of x, derivative of y1 with respect to x, plus a sub n of x times y1. Ito yung first group. Tapos, balikan ko to. Yung second group ko naman, yung mga natitira, ay ito. Okay? Lahat sila ay may C2. So, pwede kong i-factor out yung C2. Matitira lang ay a sub 0 times derivative ni y2, nth order, a1 times n minus 1th order derivative ni y2, all the way up to here, a sub n times y2. So let me write that down. Okay, plus, so equal to dun sa nasa taas, plus c2 times essentially this guy, pero si y2 naman yung nakalagay. Right. Copyin ko lang to. Tapos lahat ng y1, papalitan ko lang ng y2. So, y2, ito ay y2, ito ay y2, y2. Okay? Okay ba yung simplification so far? Do you guys follow? Okay, I hope you do. So, isa lang siyang mahabang simplification, all right? But what can we say about this highlighted term? Saan to equal? Sige nga, simplify. C1 times. Saan equal yung naka-highlight na yellow? Okay, sabi ni Zaira, 0. Sabi rin ni JR, 0. So, and then sabi ni Kiefer, yeah, sir, yan yung nasa left-hand side ng GLDE. Yeah, you're all correct. Bakit siya naging 0? Kasi remember, ang assumption natin dun sa theorem, si Y1 ay solution ng GLDE. So, ibig sabihin, si Y1 ay solution ng GLDE. So, Y1 is a solution of this GLDE. Ibig sabihin, pag yung mga Y's dito ay pinaltan ko ng Y1, equal daw yon kay 0. Which is exactly the highlighted expression here. Ito yung nasa kaliwa ng GLDE na yung Y ay pinaltan ko ng Y1. Dahil si Y1 ay solution ng GLDE natin na homogeneous, this guy will be equal to 0. Plus, the same thing happens for the second term or the second group. Kasi ito ay yung eksaktong GLDE na given, yung homogeneous GLDE natin, yun nga lang yung Y ay pinalitan ko ng Y2. Pero by assumption dun sa theorem, si Y2 ay isang solution ng GLDE. So ibig sabihin, pag si Y ay pinalitan ko ng Y2, this expression will also become 0. Kasi yun yung sabi sa GLDE. So this expression will always be equal to 0 since y2 is a solution of the homogeneous GLDE. So this will be 0, C2 times 0, which is equal to 0. So essentially, what we have shown is, pag binalikan mo yung GLDE, itong GLDE na to, tapos pag pinalitan mo si Y ng C1Y1 at C2Y2, napakita natin na masisimplify ko yan into 0. So ibig sabihin si Y, which is basically any linear combination of Y1 and Y2, will also be a solution of our GLDE. Okay? So, ito yung isang paraan paano pa makakuha ng napakaraming solutions sa isang homogeneous differential equation. Kumuha ka lang ng dalawang magkaibang solutions, kunin mo yung linear combination nila, you will get another solution to your GLDE. Okay? Is that good? Medyo madaya to kasi 0 yung right-hand side. Ano? So, that's why this happened. There's another alternative proof. Pero it's for you to decipher kung paano yung alternative proof. Pero I have presented you one proof. So I guess that's fine. Now let's see another theorem. Theorem 3.1.2. Okay. So ito ay mas generic version ng 3.1.1 kasi sa Theorem 1, okay, ang pinakita lang natin ay dalawang terms. Pero paano kapag marami ka ng solutions ng homogeneous GLDE? Meron kang 30 solutions na magkakaiba ng homogeneous GLDE. Then still, any linear combination of those 30 solutions will also be a solution to the GLDE. Alright? Kasi parang ano lang to, instead na dalawang terms, magkakaroon ka lang ng 30 terms. So the same idea in the proof will occur. You'll just use the linearity of the differential operator. So hindi nagmamatter kung ilang magkakaibang solutions yung meron ka kunin mo yung linear combination nila, makakuha ka pa ng additional solution dun sa GLDE. Alright? That's what Theorem 2 is telling us. Now, Theorem 3, ito yung may isa pa. Okay, ano yung mangyari kapag ka non-homogeneous naman? Okay, so kapag ka meron kang isang non-homogeneous GLDE, meaning R of X is not necessarily equal to 0, then tapos siya ay normal. Nagkataon na siya ay normal sa isang interval I. Tapos, let me see. Tapos magbibigay ka ng initial conditions. So meron kang constants, y sub 0, y sub 1, y sub 2, hanggang y sub n minus 1. Then there exists a unique solution, y equals f of x, such that nasa-satisfy yung iyong initial conditions. So ito yung tinatawag natin na initial conditions. So Theorem 3 is telling us, if you have an order n GLDE, all right? In general, it doesn't matter if it's homogeneous or not. Basta meron kang general linear differential equation. Tapos order n siya. Tapos nagkataon, normal ito sa interval I. So kapag ka normal ito sa interval I, magbigay ka ng kahit anong n initial conditions. Meaning you set f of x sub 0 to be equal to, or actually dapat hindi ito f. Dapat ito ay y. So kindly check your copies, alright? Okay. Kapag ka yung function value ni y at x sub 0, sinet mo sa constant y sub 0, yung first derivative kay x sub 0 ay sinet mo sa number y sub 1, hanggang makarating ka sa n minus 1 derivative of y evaluated at x sub 0, at inimpose mo dapat equal yun sa constant y sub n minus 1, then may makukuha kang unique solution. So, di ba, nakita natin Theorem 3.1.1, 3.1.2, there would be infinitely many solutions to a homogeneous linear differential equation. Alright? Pero kung gusto mo ng isang unique solution sa kahit na anong GLDE, basta siya ay normal, alright? Homogeneous man siya or hindi, magbigay ka lang ng n na initial conditions. Kung order n yung differential equation mo, okay? Pag nagbigay ka ng n na initial conditions, ibig sabihin ito yung function values ni y prime, ni y double prime, hanggang kay n minus 1 derivative ni y at the initial value of x, which is x sub 0, pag kinonstrain mo sila na ito dapat yung value ng mga derivatives hanggang order n minus 1 kay x sub 0, alright, meron ka mahanap na unique solution. So kailangan mo ng n initial conditions para ang isang normal GLDE ay magkaroon ng isang unique solution. Kung kinulang ka, kung instead na n initial conditions yung binigay mo, halimbawa naging n minus 1 lamang yung initial conditions na binigay mo para sa isang n-order GLDE, then hindi unique yung solution mong makukuha. Or hindi guaranteed na unique yung makukuha mong solution. Ang sinasabi ng Theorem 3, kapag ka order n, normal GLDE, kailangan magbigay ka ng n na initial conditions, meaning function value at x sub 0 ng function itself, value ng first derivative kay x sub 0, hanggang sa value ng n minus 1 derivative kay x sub 0, dapat ibigay mo kung ano yung gusto mong value, saka ka lang makakakuha ng isang unique solution. Okay? So too much of a theory here, pero ang summary lang ng Theorem 3, order n differential equation, kailangan mo ng n initial conditions para maging unique yung solution. Alright? So let's see some illustrations of these theorems. So umpisa natin. Meron akong second order GLDE rito na homogeneous. Si y double prime plus y equals 0. Okay? So simple siya, second order. Now, we can easily verify that sine x is a solution of this ODE. Bakit magiging solution si sine x? Palitan mo lang si y ng sine x, i-simplify mo, makukuha mo ay 0, right? Kasi if y is equal to sine x, then the first derivative is cosine x. The second derivative is negative sine x. So second derivative, so that's negative sine x plus y, which is sine x, that is always equal to 0. So therefore, we can say that y equals sine x is a solution of y double prime plus y equals 0. Kasi yung second derivative ni y prime, ni sine x, idagdag mo sa sarili niya, ang sagot ay 0. So meron na tayong isang solution doon sa ating homogeneous GLDE. Tapos makakahanap pa ako ng isang solution. It can easily be verified that cosine x is another solution to y double prime plus y equals 0. Kasi ang second derivative ng cosine ay negative cosine. Idagdag mo siya sa sarili niya. So you have y double prime, which is negative cosine, plus y, which is cosine, that will be equal to 0. Hence, second derivative of cosine plus cosine is equal to 0. Therefore, cosine x is another solution of our GLDE. So by theorem 3.1, okay, so by theorem 3.1, any linear combination, or 3.1.1, any linear combination of sine and cosine will be a solution to y double prime plus y equals 0. So therefore, ang general solution natin sa y double prime plus y will take the form c1 sine x plus c2 cosine x. So basically, hindi pala ito lang yung solution. Ang gusto kong sabihin ay itong y na to ay another bunch of solutions. Kahit ano pa si C1 at saka si C2, kapag kinuha mo yung C1 sine x plus C2 cosine x, solution din to ng y double prime plus y equals 0. So you can double check by computing y double prime plus y. Kung ito si y, masisimplify nyo equal yan kay 0. But actually, you don't need to do that kasi na-prove na natin yung theorem 3.1.1. Alright? So isa tong solution. But at the moment that I give two initial conditions, all right? Kasi anong bang masasabi natin? Normal ba tong equation na to? Ang ating A0 ay constant na 1. Ang ating A2 ay constant na 1. Ang ating forcing term ay 0. Lahat sila ay continuous. Yung A sub 0 natin, which is the coefficient to y double prime, is equal to 1. It will never be 0 in any interval. So ibig sabihin nito ay normal. Isa siyang normal GLDE. So at the moment that I give two initial conditions, then I will have a unique solution. Nakita natin ito yung general solution. There would be infinitely many solutions of the form C1 sine x plus C2 cosine x. But at the moment that I impose two initial conditions ng y sub 0 ay equal kay 0 at saka ang y prime of 0 ay equal kay 1, magkakaroon na lang ako ng unique solution. Yun yung sinasabi ng Theorem 3. Kasi ito ay second order normal GLDE. Nagbigay ako ng dalawang initial conditions, meaning the values of y and its first derivative sa x equals x, sa x sub 0 equals 0. So ibig sabihin magkakaroon na ako ng unique solution. Kasi dalawa yung initial conditions ko, order 2 yung aking normal GLDE. And then let's verify that. Okay? So ito yung ansatz natin. Ito yung hula natin dun sa solution. So meron akong solution, dapat ganito yung itsura niya. Or kahit anong function na ganito yung itsura ay magiging solution ng normal GLDE. Pero anong mangyayari pag nag-impose ako ng dalawang initial conditions? When I impose two initial conditions, we will see na magiging unique na yung solution natin. Okay? So, dahil gusto ko ng y sub 0 ay equal kay 0, so ibig sabihin gagawin ko rito, magpa-plugin ako ng x equals 0. So I will have y of 0 ay equal kay c1 sine of 0 plus c2 cosine of 0. But sine of 0 is 1. Sine of 0 ay 0. Tapos ang cosine ng 0 ay 1. So ibig sabihin this will be equal to c2. But the initial condition that we impose, dapat kapag ka ang x ay 0, ang y dapat ay 0. So basically, this must be equal to 0, telling us that C2 must be equal to 0. Okay? So, ibig sabihin, ang ansatz na natin ngayon, si y ay equal kay C1 sin x. Ito na lang yung natitirang candidate after imposing the first initial condition. All good? Okay? At makikita nyo na second order to, pag isa lamang yung initial condition ko na binigay, meron pa rin akong infinitely many solutions kasi it doesn't matter what the value of C1 is. Posible pa rin siyang maging solution. But remember, dalawa yung binigay kong initial condition. Okay? So, yung isa pang initial condition, dapat daw yung y prime of 0 ay equal kay 1. Okay? So, remember, yung ansatz na natin kanina, nakita na natin na ang candidate na lang natin para maging solution ay si y equals C1 sin x. Pero pag kinuha ko si y prime, ito ay equal kay C1 cosine x. Alright? Pero yung initial condition natin para sa y prime, dapat daw equal to kay 1 kapag si x ay 0. So when x is equal to 0, we should have 1 equal kay C1 cosine ng 0. Kasi ang x natin ay 0. But cosine of 0 is 1, so that means C1 must be equal to 1. And this will give us our unique solution. Therefore, the unique solution that satisfies both of our initial conditions is y equals sin x. Okay? Nandun tayo sa ansatz natin kay y, pero ang C1 dapat ay 1, so we'll have y equals sin x. So you see the reduction. Kung GLD lang yung given, we'll have infinitely many solutions. Ang itsura ay C1 sin x plus C2 cosine x. Pag nagbigay ka ng isang initial condition, mababago or mababawasan yung solutions. In fact, nung sinet natin na ang y of 0 ay equal kay 0, natira na lamang ay infinitely many solutions pa rin naman, pero ang form niya na lang ay C1 sin x. But once I impose the second initial condition and I have an order 2 GLDE, ibig sabihin magiging unique na yung solution. And true enough, we were left with only the sine function as our solution to the second order normal GLDE. Okay? Does it make sense? Medyo conceptual tayo ngayon, no? So, but I hope you guys still follow. Hopefully, andyan pa rin kayo. Hindi kayo nag-Netflix dyan sa tabi. Alright. Ano bang bago ngayon sa Netflix? Hindi nyo ako maluloko kasi naging estudyante rin ako ng online class. Ano? I think during my last year, nung nagpi-PhD ako, online yung mga classes namin. At alam ko yan kasi sa office ko noon, tatlo yung screens ko. Meron akong dalawang screen dun sa office PC ko. Tapos meron akong dalang laptop. Tapos may dala pa nga akong tablet. So lahat sila naka-open. So nag-play yung teacher ko. Tapos ako, alam nyo na, nag-Amazon dun sa kabila, nag-eBay sa kabila, nag-Netflix dun sa kabila, and so on. But I hope you're still following, even if you are multitasking. Any questions? Parang mas nakakahirap pala mas mahirap mag-discuss ng conceptual kaysa sa methods, ano? Pero I hope this is a breath of fresh air na yung buong chapter 2 parang computational lang tayo palagi. Pero ngayon medyo may theory na nakasama. Alright? Okay. Now, let's try another one. So, for this example, ito naman yung isa-solve natin. Y double prime minus y equals 0. So, it's a second order GLDE. I hope you agree. It's homogeneous kasi 0 yung right-hand side. And then, ang a sub 0 natin ay constant na 1. Ang a sub 1 natin, which is the coefficient for y prime, it's a constant 0. Tapos si a sub 2, which is the coefficient to y, ay equal kay negative 1. Ang ating forcing term ay equal kay 0. All of these guys are constants. So, ibig sabihin, continuous lahat sila. Tapos si a sub 0, the coefficient to the highest order derivative ay never nagiging 0 sa kahit anong interval. So therefore, we can say this is normal. This is a normal GLDE of order 2. Okay? So, pag nag-impose ako ng dalawang initial conditions, meaning initial condition, ibig sabihin condition dun sa initial value ni x. So you can think of the initial value of x to be 0. Ang value dapat ni y kay 0 ay 4 at ang value dapat ni y prime kay 0 ay 2. So meron tayong dalawang conditions. Meron akong order 2 linear differential equation na normal. So ibig sabihin makakahanap dapat ako ng unique solution. Kasi yun yung sabi ng Theorem 3. Okay? But the general idea here na makikita natin, i-revisit natin later when we look at specific methods. Kailangan nyo munang humanap ng solution doon sa homogeneous system. Paano maghanap ng solution? Well, i-discuss natin yan all throughout chapter 3. Paano nagsosolve ng homogeneous differential equation. Pero for now, makokontento muna tayo sa pag-verify ng solutions. Given muna yung solutions kasi ibang usapan kung paano sinusolve yung homogeneous differential equation. Matututunan natin yan in succeeding sections. Pero for now, let's use the fact that e to the x and e to the negative x are both solutions of this differential equation. Madali lang siyang i-verify kasi kapag ka si y ay e to the x, ibig sabihin ang y double prime ay e to the x din. So y double prime minus y, so that's going to be e to the x minus e to the x, that will be equal to 0. So indeed, e to the x is a solution to this differential equation. All right. Another solution is y equals e to the negative x. Kasi kapag ka si y ay equal kay negative x, ang first derivative ay negative e to the minus x. Tapos ang second derivative ay e to the negative x. You have y double prime minus y. That will be equal to e to the minus x minus e to the minus x. That will be equal to 0. So indeed, y equals negative x is also a solution to our differential equation. Okay? So totoo yung sabi ng handout na parehas itong dalawa ay solutions. Then we use either Theorem 3.1.1 or Theorem 3.1.2 na any linear combination of any solutions is another solution to the homogeneous differential equation. Meron tayong homogeneous differential equation, so kunin ko yung linear combination nitong dalawa na to, I'll get another solution, right? So therefore, our ansatz for our solution is y equals c1 e to the x plus c2 e to the minus x. Ito yung general form ng ating solution. Alright? Ito yung hula natin. Ito yung template natin o yung ansatz natin para dun sa ating solution. Okay? Kaya lang, there are infinitely many such possible functions kasi si c1 at saka si c2, they can take any constant value. Right? Pero at the moment, tama ba yung ato dapat in? In the moment, at the moment, basta sa moment na inimpose ko itong dalawang initial conditions na to dun sa aking order 2 normal differential equation, instead ng infinitely many solution, I will reduce it to one and only one solution. Okay? So tingnan natin, paano siya mangyayari? Well, hindi ko pala sinulat. Hindi ko kinopy-paste yung solution. So, mano-mano natin to gagawin. Kaya siguro ako nagtatagal kasi mano-mano ko siya ginagawa. Pero I think that's fine. Kaya sa swipe lang ako ng swipe para din sa solution. Alright? So, but I hope you got it. This is our ansatz. And then we are imposing these two conditions. Kopyahin ko lang to. Okay, yan yung gusto nating initial condition. So I will impose these two conditions, right? So if x is equal to 0, we should have the following. First, we have 4 equals c1 e to the 0 plus c2 e to the negative 0. All right? Kapag ka daw si x ay pinalitan ko ng 0, dapat ang y ay magiging equal kay 4. So lahat ng x's pinalitan ko ng 0, si y ay naging equal kay 4. So essentially, I have C1 plus C2 equals 4. Okay, in the same manner, if I get y prime, okay, compute natin yung y prime. So this is C1 e to the x minus C2 e to the negative x. Tapos, pag nag-plug in daw ako ng x equals 0, dapat 2 yung value ni y. So that means if x is equal to 0, then we'll have this. Dapat equal kay 2 si y prime. So I'll have C1 e to the 0 minus C2 e to the negative 0. But this is just C1 minus C2 equals 2. Okay? And then I will solve etong system na to. Meron akong system of equations 2 by 2. Dalawang unknowns, C1 and C2. So dalawang equations, so dapat meron tong unique solution. And the solution can easily be found by using elimination. Pwede kong i-add itong dalawang equations na to because if I add them, C2 will vanish. May eliminate si C2. So that means I'll have 2C1 equals 6, right? So C1 plus C1, that's twice C1. C2 minus C2, that's 0. 4 plus 2 equals 6. So this gives us C1 equals 3. Tapos dahil alam ko na si C1 ay 3, I'll go here in equation 1. So kayo na lang yung mag-arrange ng maganda dun sa solution. All right? So it would be a nice exercise to write this in an orderly fashion. Ano? So ako na yung gumawa ng scratch work. I-organize nyo lang siya into your solution. But I can go back to either this equation or this equation and plug in C1 equals 3. I'll just choose arbitrarily to work with the first equation. So I'll have 3 plus C2 equals 4. That means C2 is equal to 1. So therefore, the unique solution we're looking for is y equals 3 e to the x minus, plus e to the minus x. So dun sa ating ansatz kanina, si C1 papalitan ko lang ng 3, tapos si C1 papalitan ko lang ng 1. And we get our unique solution. Okay? And then I hope you notice here that the unique solution to our IVP. IVP na to kasi meron na tayong initial conditions na binibigay. Yung unique solution sa IVPs ay nakatali yung sa pagkakaroon ng solution dun sa homogeneous system. So we're just particularizing our general solution following the initial conditions. At dahil meron tayong normal GLDE, tapos of order 2 siya, tapos meron tayong dalawang initial conditions, then Theorem 3.1.3 guarantees that we will get one unique solution. Okay? Is that clear? Any questions, comments? Okay, and then I think I can leave the practice exercise to you. Ito pala, dun sa may isa sa inyo nakakapansin na dun sa mga homeworks na binibigay ko, medyo na-copy-paste yung ibang examples, ano? So just refrain from submitting as homework yung mga sinagutan natin sa klase, ano? Yun na lang yung general rule. Para kung nakalimutan ko man siyang i-delete dun sa homework, hindi niyo na siya sasagutan by default, ano? So pag sinagutan natin sa klase, wag niyo na siyang i-submit sa homework kahit nandun siya sa homework sheet, ano? So ibig sabihin nakalimutan ko lang siyang i-delete. So do you want to have a homework or wag na lang muna? Pahinga na lang muna tayo ng reading break. Nagsimula na yung malakas na ulan. So hopefully hindi pa ako nawawala sa internet. Okay, any questions? May tanong ba? Okay, so if there are no questions, then sige, gusto niyo ba mag-homework or wag na lang? Wag na lang muna, reading break na lang, no? Sige, but I hope when you find time or na-bore na kayo during the reading break, try to answer the practice exercises. Kasi remember, these these topics are still covered in the midterm exam. All right? So, hindi na lang muna ako magpapa-homework para ma-enjoy nyo yung reading break. Pero pagbalik natin ng reading break, make sure you are back to academic shape because a week after we go back after the reading break, we will have the midterm exam. Again, that would be on November 7, 4 to 6 p.m. sa math building. Okay? Any questions? So kung wala na, so thank you guys for joining me today. We'll meet on Friday. And for that, we'll try to finish sections 3.2 and 3.3. All right? Para pagbalik natin from the reading break, itatackle na natin yung 3.4 to 3.7. I'll try to negotiate the coverage of the midterm exam, pero prepare na ang coverage ng midterm exam ay hanggang chapter 3.7. Pero there is a chance that mapapababa ko siya at least hanggang sa topic natin today, all right? Para hindi na natin isasama sa midterm exam yung i-discuss natin week after the reading break. Pero no guarantees yet. So at the back of your mind, still prepare that the coverage of the midterm is until section 3.7. But again, I'll try to negotiate to limit it down, okay? Para hindi masyadong marami. Okay? So yeah, keep safe guys and let's see each other again on Friday. All right, bye.